I have a weird feeling that my talk will be somehow related to the previous one. I just cannot really pinpoint how. So if you can do that for me, welcome. So I represent Nunet, and the way we kind of explain ourselves what we're doing in one sentence is that we're building a global economy of decentralized computing. And that means that a computing framework where anyone basically can share and monetize their computing resources at scale and provides globally distributed and optimized computing power for decentralized networks. Which means it's an open source platform for connecting individually owned compute devices across the world into a decentralized cloud. By the way, most of the things that I will say, basically everybody is doing here, which is kind of both exciting and annoying at the same time. Then all the resources are freely accessible for the ecosystem of data providers, storage frameworks, AI developers, and basically everything that makes computing a computing framework. And we are working to select use cases towards using the platform for fully functional real-world applications. And we are kind of working towards building those use cases while we're building a platform, which is another challenge. Oh, I see, same slide here. So basically, again, what we are trying to solve, something that everybody here is, or at least most of us are trying to solve, is that utilization of latent compute resources, which are scattered around the world, connectivity between devices, software, hardware, localities from different vendors, etc., and so on. And basically trying to get something that is by design robust and secure, which is something that let's say, centralized frameworks cannot achieve by design again. And that what we are particularly looking to is machine-to-machine interactions and economy, where every aspect of the system can pretty much participate in the economy and exchange value, not only data, but also value between themselves, which means paying to each other. Which hopefully would sort of get organized into a self-optimizing compute engine, globally distributed or decentralized. And that in terms of use cases, we're looking for Web3 use cases, but also we're looking for the Industry 4.0 so-called and IoT use cases, which seems to me that these use cases are something that all the basically decentralized computation is most useful for that, pretty much, again, by design. And so that is a kind of like picture that we were figured out in the very beginning, that what we want to be a layer between the algorithms in this decentralized system and the hardware, decentralized hardware, which means deployment layer and the crypto, well, let's say, doesn't matter whether it's crypto or not crypto, but micropayments layer, which allows to for each agent to pay to each other for the inputs and outputs. Now, and that creates an economy of computing. So what is economy? Basically, well, first of all, what is computing? So we can imagine it as there is data processing and connectivity over hardware and software. So all these combinations makes computing happen. And now economy or marketplace is sort of can be defined as interaction of independent economic actors, which means this actor is independent from each other. And then the framework that makes them interact and sort of do something more than they can do individually, produce an economy. Which means we need interaction between those components and ability for them to transfer value for the work that they do individually. And that's exactly what we're trying to do, which means we're trying to build a population of independent compute devices, software agent, application developers, basically everything that makes this computational framework. And on top of that, building a tokenomics layer, which will provide the ability to exchange value between those agents. And hopefully, that will sort of bring about dynamic assemblages of useful computing within this framework. So it also relates to basically self-organizational dynamics of this economy of decentralized computing. And as I mentioned, one of the use cases which seem to me, or let's say classes of use cases that seem to me most appropriate for this kind of framework or in general, decentralized computing, IoT or edge computing, which somehow was a big promise 10 years ago or so, and it didn't seem to be kind of fulfilled. And I believe it's pretty much because in order to build these kind of frameworks, you need an interaction between many actors, software, hardware, etc., which do not really belong to one entity, which means you have to build economic framework into the computing in order to make that happen. So which means we need communication between them, as well as machine-to-machine payment channels in order for them to exchange economic value. And in compute over data context, as I said, it seems that we are kind of pretty much looking to the same direction. And the way to solve it, we see a lot of frameworks which are kind of building around the same. And the way basically we can go about it is either adopt time-tested kind of commercialization methods, which means that we can just build our frameworks in somewhat isolated and allow users to choose whichever they consider best. Or we can learn from each other by basically in open source manner, looking at each other's code and sort of taking snippets, or maybe participating in each other, let's say, development efforts. Or we can build a marketplace of what we call marketplace of marketplaces, where we can enable basically each framework to build components within this decentralized computing universe to basically use each other and exchange value between each other, sort of without necessarily copying each other's work. So imagine, for example, taking this example of IoT networks, suppose we can have a marketplace of marketplaces where different agents in that marketplace are exposed by different projects within this COD ecosystem while talking in the same language. So one of the early images of NuNet that we had, I guess in our first website when we launched, was this kind of connectivity between different frameworks within the, let's say, within API of APIs, which we call natively. Again, enabling communication between them as well as value exchange. So that's basically API of APIs. And in order for doing that, what we are trying to do internally, both for our own, let's say, life cycle of the platform, as well as integrating internal within the ecosystem and external projects, is pluggable API system where we can define APIs and then like abstract all the functionalities that we're doing, and then allow, let's say, others, first of all ourselves, to define, to like write things based on those functionality and allow others to expose their functionality, expose these APIs through their functionalities. Now, basically the model that we are, again, quite a few projects seem to be doing that, is doing what's called commercial open source software, which means that they are looking for the commercial use cases on top of open source software, which kind of, and again, the ability to interact, to have the communication layer as well as payments layer, pretty much allows us to use open source, and what's going on here? Open source and the proprietary software within the same framework. Now, that brings us to the economy, which means we are built sort of this kind of economy of distributed computing or decentralized computing has to pretty much allow interaction between different stakeholders, not just computing, let's say, entities, but stakeholders. So I'm just jumping now into the concept that the way we are building, or we are trying to bootstrap this economy, is by finding the closest use case to the level of technology that we have, implementing it, and based on that, sort of looking which next can we take. So right now we are on the testnet public alpha release, what we call, which means that we have the first use case implemented sort of end-to-end, where users can pay for the compute jobs, and these compute jobs can be delivered to the decentralized network. And then when they are correctly, hopefully correctly sort of executed, the compute devices can get, let's say, rewards from the escrow account that was locked before the computation started on agreed terms. And we expose that to our community testers and trying to basically bring it, this particular use case, bring it to the level where we can release it on mainnet and allow actual, let's say, value exchange. And based on that, we will go towards the next and more kind of complex use cases. Now, imagine if we can do these kind of use cases by plugging in different components from the different, let's say, projects or frameworks that are, well, which are participating in the compute over data working group of the community. And this is pretty much what we're looking for. Now, in the context of Juan's triangle, so sorry, I use a picture, hopefully that's okay. But basically, if we figure out how can we dynamically choose execution frameworks and networks based on the requirements of specific computations, and we can place those different computing, let's say, tasks within the network, which together can, I mean, where they can communicate between each other, maybe we can somehow solve this dilemma by doing computations where they need to be based on the requirements. So when they need privacy, we can do computations that are private. When they need performance, we can do computations when they are, let's say, bring performance and verifiability, etc., and so on. And then by putting the tokenomics layer on top, we can basically combine them into one computation engine. So, and hopefully, yeah, solve the dilemma. So, and I will leave you with this idea. So, thank you. So now, I will ask a question. Did you find the similarities between this talk and previous one?
So I'm curious about your incentive structure. Is it pay for compute, or do you have a Genesis event to incentivize people to contribute compute?
Sorry, didn't hear.
Is your incentive structure, is it like tokenomics or crypto economics? Are you paying for compute, or is there a Genesis event that's subsidizing people who provide compute to the network?
Well, what we're trying to do, we are trying to do none of that, which means connecting people who want to pay for the computing power and those who would like to, let's say, get rewarded for the free computing power, or anything that sort of describes computation in any workflow. Does that answer anything?
Yeah, I think so.
But actually, we do have certain incentive structure, or let's say not structure. Actually, right now it's just a fund, but at least we are building this incentive structure. But these incentives will be used for bootstrapping the network, because in order to make it work, as in kind of in economy, you cannot just have a couple of actors. You need to have a scale of producers, let's say compute providers and compute suppliers and compute users. So we'll use that in order to bootstrap the whole, let's say, economy, or at least we are planning to do that.
Cool. If you got a scoreboard of people providing compute, you can plug into Gridcoin and we can just incentivize you really easily if that makes it simple. We can talk later.
I think we're done. Thank you very much.
Thank you.